This is a quartic polynomial, and our goal is to solve this one. Figure out what values of x we could plug in, evaluate it for this expression, and then does it come out equal to 0? There's no easy algebraic way for us to solve this right now, and so what we're going to do is use the graphing calculator as a tool to come up with the solutions to this. So what I'm going to do is enter this equation into my graphing calculator as y equals. So I have y equals x to the fourth plus x cubed minus 37x squared minus 7x plus 210. If I hit the graph button, here's what the graph looks like, at least part of it. And if I go back to the equation itself, this equation is equal to 0. If I think about y being equal to 0 being equal to that, then anywhere that that graph has a y value equal to 0 would be a solution. So back onto my graphing calculator. Here's a y value of 0, there's another, and another, and another. I want to figure out what those values are. One way to figure them out is to go to the table, so hit second graph, which is table. And what I see then is that when x equals 5, y equals 0, and if I scroll up a little bit further, when x is negative 6, y equals 0, so there's two solutions. I knew to look for those because as I look on this graph, it looks like this one is negative 6, it looks like that one is positive 5. So right now I know that two of the solutions are given from this graph at negative 6 and also at positive 5. Now there's two more solutions that I see by looking at the graphing calculator. One right here, negative 1, 2 point something, and one over here, positive 1, 2 point something. I can't quite tell what they are. If I go back to the table, I can see that between an x value of 2 and an x value of 3, the y values switch from positive to negative. And between negative 2 and negative 3, the y values also go between a positive and a negative. So I know that there's something in there. To figure those out, I'll go back to the graph, and I want to calculate this 0. So I'll go to second trace, which is calculate. We want to go down to 0, and it asks, what is the left bound? So right now there's a cursor on the graph that I can't quite see, and the x value is 0.3, the y value is 204. So if I scroll to the left, you can notice that those numbers are changing. And the y values are getting smaller. They're still too big to see on the screen. They're dropping a little bit quicker now. So all of a sudden we have this point, negative 2, positive 49. Drop it again. And again, all of a sudden I can see the cursor showing up. It's at negative 2.5, positive 9. If I go left one more time, all of a sudden it's not on the screen anymore because it's too low. But I'm to the left of that point. So I'll hit enter. Right bound. I'll hit the right arrow one time. Now I'm to the right of where that point is out. I'll hit enter again. I don't need to guess. And then it'll tell me that this point is at negative 2.65 comma 0. That is one of our zeros, one of our solutions. So x is also about negative 2.65. Go back to the graph, and now I need to figure out this point. So I'll go back to second, calculate 0 again. Scroll to the right. I'm looking for a left bound here, and I'm following those numbers across the bottom. So right now it's 0.3 up 200, so it's still too high. I'll just make it go right a little bit further. Hit enter. That's the left bound, so I'm looking to the left of that point. Now I need to scroll over quite a bit further. And now I'm to the right of where that, let's go a little bit further. I can see the y value is negative, so I'm a little bit to the right of that point. I want to find what is the 0 in between those two borders. I'll hit enter for the guess because I don't care. And then the 0 is positive 2.65 comma 0. So I have these two exact values and these two approximates. In an Algebra 2 class, we could figure out what are the exact values here by using a process called synthetic division. There's also a rational roots theorem we could have used to find some of these solutions. But for a geometry standpoint, if we're just looking for decimal answers, I can use that calculator to come up with all 4 solutions to this one.